This is the final anion test that I'm going to show you, and this is for halide ions. So the things that count as halide ions are chloride ions, bromide ions and iodide ions. So I'm doing all three as a sort of parallel test. So this contains the chloride, this middle tube contains the bromide, and this end tube contains the iodide. Now we've got that same dilemma that we had before. We've got to add an acid to them to neutralise any hydroxide ions or remove any carbonate ions that might be contaminating them, and then I can add my test reagent. So let's just have a little look at what might be a good choice of acid to use. So for the halide test, I've got hydrochloric acid available to me, sulfuric acid potentially if I wanted it, or nitric acid. My test reagent is silver nitrate. So hopefully you're looking at those two acids and you're deciding which would be the sensible choice and which would be the stupid choice about an acid to use. So I'll just give you a moment to think about that. I'm hoping that you've realised this would be the good choice because its ion matches the ion in my test reagent, and this would be the terrible choice because it's got a chloride ion in it which actually matches one of the things that I'm looking for. So it would effectively contaminate or pollute my test because I would be adding the very thing I was trying to see if I had in my sample. So that's a terrible choice. Nitric acid would be a good choice. So let's have a go. So I'm going to add some nitric acid to each of these in turn in order to make them into solutions. I'm expecting that when I add my silver nitrate to it, I should make precipitates, a different precipitate in each one. So in the sample containing the chloride ions, I should make silver chloride. In the one containing my bromide ions, I should make silver bromide, and the final tube should end up forming silver iodide. Okay? Now, these silver precipitates, silver chloride, silver bromide, silver iodide, all have different distinctive colours. And we're quite lucky today because it's quite sunny. They also change colour in the sunlight, so I might be able to show you the final colours that they end up as well. So I'm doing this parallel testing so that you can see the comparison of the different colours. So let's add some silver nitrate now. Okay. Silver nitrate into the chloride. Right. That's giving me my first colour. This one into the bromide. Now, I don't know about the colour resolution on the film here, whether you're going to be able to see much difference between them. And again, in real life, it's not brilliant, the colour difference. We sometimes refer to them as milk, cream, butter to help us remember the different colours. This should be white, this should be cream, and this one should be yellow. Now, the reality is that this middle one is very tricky. Sometimes it looks very pale and looks like this. Sometimes it looks quite dark and looks more like this. And in fact, today, it looks more like the iodide tube. And if you were to study this at A-level, we learn a further test that we can do in order to help distinguish between those more carefully. But these are the colours of them. The chloride forms a white precipitate, the bromide forms a cream precipitate, and the iodide forms a yellow precipitate. I'm going to take them out into the sun and bring them back in a minute, and hopefully they'll look a different colour for you. So I've been out in the sunshine with these and brought them back in. I hope you can see that they are different colours. I'm just going to stand this white board behind them and I hope that makes the colours a bit easier to see. Okay, now these silver salts used to be used in old photographic films because they're so light sensitive. I don't know if you can see, this one was white and it's gone, well, we describe it as lilac, the colour on that. Okay, this one, this is, I think, a hilarious name for a colour, it's called buff. I think these days we'd probably call it kind of greyish colour, sort of mixture between grey and beige. But this one is a cream precipitate that goes buff in the sunlight, don't we all? And this yellow one in the end hasn't really changed colour at all. Okay, so that's quite a handy way, if you've got some sunshine available, that's quite a handy way to discriminate between them because of this sort of final colour that they end up. But as I said, if you were to go on and study this at A-level, you learn a better chemical test to distinguish between them at this stage.